Assalamualaikum and hi. Today we would like to present our mini project for ECS268 Structure and Material Laboratory. The title of our project is Sustainable Hollow Brick Production. Before we proceed, let me introduce our group member. Our group consists of 4 members. First, Nur Syasmin Deni binti Muhammad Safwan, Nurin Auffa binti Amir Adha, Najwa Hazika binti Muhammad Muhammadiyah, and Zanatul Ayu Natasha binti Rosli. The purpose of this project is to develop a sustainable hollow brick by replacing 25% of coarse aggregate with recycled concrete aggregate (RCA), thereby reducing depends on finite natural resources and mitigating the environmental impact of the construction waste. Moving into our project scope, we have structured our engineering framework using 4 fundamental pillars: materials, geometry, methodology, and evaluation. First, for material selection and replacement, we established a strict parameter framework utilizing a fixed 25% replacement of natural concrete aggregate. Second, looking at geometric design, our focus is especially applied to a hollow brick profile, which strategically reduce the overall structural dead load. To ensure the validity of our result, our methodology standard relies on strict adherence to establish laboratory protocol for specimen fabrication and testing. Finally, our primary parameter for testing and evaluation is establishing the precise compressive strength of this sustainable alternative, ensuring it meets all structural safety benchmarks.
These projects contribute to sustainability in several ways. Firstly, it helps redirect structural demolition waste by reusing waste concrete as recycled concrete aggregate instead of sending it to landfills. Secondly, by reducing the use of new raw materials, this project also helps lower emissions such as carbon dioxide, sulfur dioxide, and nitrogen oxides. These gases contribute to climate change, acid rain, and global warming. In addition, this project supports a circular economy by converting construction waste into useful building materials instead of disposing of it. It also helps preserve natural resources by reducing the need to extract virgin aggregates for concrete production. Overall, the use of recycled concrete aggregate provides both environmental and resource conservation benefits.
This slide shows the methodology used throughout our project. The process begins with preparing the required materials, followed by mixing, casting, curing, and finally testing the hollow bricks. Now I will explain each stage in more detail. The first step was preparing all the materials required for the mix. These materials included cement, fine aggregate, water, and recycled concrete aggregate. The recycled concrete was first crushed to obtain the required size before being used in the mixture. After that, every material was weighed according to the design mix proportion to ensure accuracy and consistency. Once all the materials were ready, they were mixed thoroughly until a uniform and workable concrete mix was achieved. The fresh concrete was then poured into the hollow brick molds and compacted properly to remove trapped air and reduce the formation of air voids. This compaction process helps improve the strength and overall quality of the hollow bricks. After casting, the molds were left undisturbed for approximately 24 hours to allow the concrete to set properly. The hollow bricks were then carefully removed from the molds to avoid any damage. Next, the bricks were cured in water for 14 days. This curing process is important because it allows the cement to continue hydrating, which increases the strength and durability of the bricks. Once the curing period was complete, several tests were carried out to evaluate the quality of the hollow bricks. These tests include checking the weight and conducting a compressive strength test. Finally, the results were analyzed to determine the effectiveness of using recycled concrete aggregate as a sustainable replacement material.
Next are the compression test results. 3 sustainable hollow brick specimens containing 25% of RCA were tested. Brick 1 achieved a compressive strength of 3.06 MPa, while Brick 2 recorded the lowest value of 1.58 MPa. Brick 3 shows the highest compressive strength of 3.51 MPa. From these results, we can conclude that Brick 3 performed the best under the compressive loading. The differences in compressive strength between the specimens may be due to slight variations during specimen preparation, such as compaction and material distribution.
3 hollow brick with 25% RCA were tested for the compressive strength. Brick 3 recorded the highest strength, 3.51 MPa, followed by Brick 1, 3.06 MPa, and Brick 2, 1.58 MPa. The variation in strength was likely due to uneven compaction, non-uniform material distribution, internal air void. The compressive strength was below recommended 4 MPa, but the brick are suitable for non-load bearing application. Using 25% RCA reduced the use of natural aggregate and show potential as a sustainable construction material. Future work, improve water content control, compaction, and extend curing to 28 days to achieve higher and more consistent strength. In conclusion, this project successfully achieved its objective by producing sustainable hollow concrete brick using a 25% PWCM replacement. The physical and mechanical properties of the brick, including compressive strength, density, and water absorption, were evaluated to assess the performance. The results show that the 25% PWCM replacement influenced the overall performance of the hollow concrete bricks. Although the brick did not perform as well as conventional concrete bricks, the finding demonstrate that PWCM has good potential as a sustainable alternative material for brick production. In addition, using PWCM helped reduce the consumption of natural resources while promoting the recycling of waste material, contributing to environmental sustainability. For future research, the MIG design can be further optimized, different PWCM replacement percentage can be investigated, and long-term durability tests should be carried out to improve the performance and reliability of the brick. This appendix contains the supporting document for our project. It includes photographs taken during the laboratory work. This is all the reference we use to refer for our study. That's all from us. Thank you.